We're going to look at the directions for drawing ray diagrams and analyzing the picture that results. We're going to start with concave lenses, and they will always produce real images, upright images, and reduced images. And you'll see that from the two diagrams, the two ray diagrams we'll do right here. Concave because this front side bends caves towards that object. But it's going to be this right here would be a diverging lens, because when a light ray comes through, it's going to bounce away from the center, from the principal axis. This is the principal axis right here down the center. So the first ray, we go ahead and we find that object. We're going to always start our rays from the arrow tip, and we're going to draw that directly parallel to the principal axis all the way to the center of the lens. Next thing, what we're going to do is we're going to keep our pencil there, but we're going to get a ruler or some sort of straight edge, and we're going to line it up with this focal point and our pencil where it's at. But since it's diverging, we're going to go ahead and draw away. And we're not going towards the focal point. We're going to draw away from the focal point, and we're going to diverge that lens. We're always drawing to the real side before we may have to come to the virtual side on some of these, especially the ray diagrams for these concave lenses. But we're going to draw it straight, lined up with that focal point into the real side. Draw the arrow tip on the refraction on the real side, and then we're going to go ahead and take step 2. We're going to draw a second ray. We're going to start from the tip, the arrowhead, and we're going to draw this one straight through, and this will be done for all lenses, straight through that central point. We're going to keep it going. We're going to draw an arrow tip on the end, and now we have 2 arrow tips that we can trace back, and we're going to trace them back, and they don't meet on the real side, but what they're going to do. And since this one's already flush, it's already full, I'm going to keep it there. I'm going to draw a dotted line right here, and I'm going to find where that ray is going to meet this ray, and that's where the image is going to be produced. So the image is going to show up right about there, and then I can analyze the image as a result. And so if I take a look at this, it's virtual, because this is the virtual side of any sort of lens, and this is the real side of any sort of lens. So it shows up on the virtual side, and that's why it's virtual. It's upright because it's facing upwards. When we draw the arrow, if we ever draw an arrow and it's above this principal line, it's always going to be facing upwards with its base on the principal line. And you'll see in later ones, if it's below, it's going to be facing downwards with its base on the principal line, but you'll see that in a bit. It's reduced because this little blue image, I just drew in a different color so I can compare it, versus the black object in the first place is reduced because it's just smaller as a result. Okay, the next one, I just went ahead and moved it a little slightly further. The object, I've moved it past that focal point, but same directions. Start here at the object's head, at the top of the object, and draw it to the center of the lens. Next, we're going to go ahead and these, with caves like this, if it's going to be diverging every single time. We're going to line up your ruler with the focal point and this, and we're going to keep our pencil still on the page right here, and we're going to draw it away, and it's going to show up like this. We'll draw an arrow tip on the end. The next ray we're going to draw straight through the central point right there. We're going to follow the arrow tips back. Follow the arrow tips back. That's going to mean that this is going to go to the virtual side. So I just draw a little dotted line to represent the virtual side. And then the object shows up right here. It's still reduced. It's still virtual because it's on the virtual side, and it's still upright, facing upwards. And just a reminder, any virtual image is always going to be upright, no matter what you have, a lens or a mirror. Okay, then we go to concave lenses. These get a little bit more difficult because there's many different types of images that can show up. And the directions are almost the same. We're going to draw the first ray from the arrow tip all the way to the center of the lens, so just like this. But now, since it's converging, we're going to line this point up with this focal point. So I really didn't need this F prime or 2F prime. I really could just use this point right here. And we're going to go ahead and line it up, and we're going to draw it through to the real side. We're just going to extend that out because we might need that sometimes on these diagrams, and draw an arrow tip on it. And we're going to get to our second ray. We're going to start back at the start, and it's the same direction as before. It's going to be through this central point all the way through, and draw an arrow tip on that. Now we have 2 arrow tips we can follow back, and it shows you that you end up right here, and we're still going to be on the real side, and that's where the image is going to be drawn. We're going to draw it with the arrow tip down since it's below this principal line, and we're going to draw the base all the way to the principal line of the arrow, and then we can analyze that. And this one itself is, I actually fixed it from before. This one actually would be, it's going to be inverted. It's going to be the same size, and it's going to be a real image. And if you ever are off a little bit, I'm going to try to make them pretty obvious for any sort of quiz or test. Sometimes they might look bigger or smaller, and I'll take that if it's a free response section. So I personally drew it wrong, and that's why I have this before. But if I'm just analyzing what I drew here, it was about the same size. I just went back and perfected it after I realized a mistake, because it's really hard to draw these perfectly to scale. We're going to use some math later on to kind of get perfect answers. With ray diagrams, you get pretty close answers. Okay, so now we take this arrow tip and we're going to move it to the focal point. And this is the one place where something weird happens and no image is going to be formed, and let's see why. First ray directly to the center of the lens. Second ray, because it's converging through this focal point, draw the arrow tip. Next ray, we're going to go ahead and start new. We're going to start back from the arrow tip. We're going to draw straight through that central point. And then we realize these things don't cross on the real side, so we take them to the virtual side. And when we take them to the virtual side, they never cross anywhere. So there's one place, and you're going to see in any sort of, with a lens, there's going to be a point where everything just disappears and all of a sudden it flips, and then we'll see the result of that. So there's no image here at this focal point, right when it's a focal point away from the lens. And then we get past that and something weird's going to happen. It's going to flip, and we'll see what happens here. We're going to start with the line at the arrow tip to the lens, and I extended out my line because I'm going to need it. I already know what's going to happen here. If you ever don't have enough line on your worksheet, just extend out the line so you can draw over the image right later on. But we're going to draw the first line from the arrow tip of the object to the center of the lens, and we're going to converge it because this is a converging lens. So we're going to draw it through this focal point. Line your ruler up so it's nice and neat, and draw an arrow tip on the end. Next, we're going to start from the start again, and we're going to draw it straight through this central point. And we'll draw an arrow tip on the end. We'll follow the arrow tips back, and they don't meet over on the real side. They're going to go ahead and they're going to trace back, and I did this kind of out of order. What I should have done next is trace back these lines through, trace back the lines through to the virtual side, and we find that the image ends up showing up right here. And so now we can go ahead and analyze this image. Once again, since it's above the principal line, arrow tip facing up, then we draw the base all the way to the principal line. And now we can look at it, and it's virtual because it's on the virtual side of a lens, which is on the side that light's supposed to go through and not bounce back off a lens. So that's why this is real over here. But in this case, this just showed up on the virtual side of the lens. If you just take a look at this lens right here, everything on the left side of it's virtual, everything on the right side is real, and it's virtual, it's upright, once again, always hand in hand, and it's enlarged because it's just bigger than the object. We just compare it to this object. Ignore the thickness, that's just the way I drew it. You just look at how tall it is. It's enlarged versus that object.